Conic sections, ellipses and hyperbolas. Conic sections are curves that result from the intersection of a right circular cone and a plane. There are four we will study: circles, ellipses, parabolas, and hyperbolas. The two we're going to focus on right now are ellipses and hyperbolas. But here's all of them. So here we have this right circular cone and a plane, which you can imagine is just like a sheet of paper, and all the different ways that that sheet of paper can intersect the cone. So if I have the sheet of paper sort of at an angle here, I can see that I will intersect the cone in this U shape called a parabola. If the sheet of paper is cutting straight across, then I create a circle. If I tilt that sheet of paper a little bit, then I have an ellipse shape, which kind of looks like an oval. And if I take the sheet of paper and stand it straight up, then the intersection looks like these two U's, which is a hyperbola. So we're going to focus on the ellipse, the oval shape, and the hyperbola. We'll start by talking about an ellipse, and we're going to focus on some of the vocabulary to deal with an ellipse and then graphing an ellipse, but there are a lot of rich applications. We don't touch on any of them, but just so you know, this comes up a lot in astronomy since we talk about elliptical orbits and how the moon orbits the Earth in an elliptical shape and the Earth orbits the sun in an elliptical shape. So there are a lot of really rich applications. An ellipse is defined as the set of all points in a plane whose distances from two fixed points called foci have a constant sum. So here we have this picture of an ellipse, and these are the foci. The singular is focus. So we define an ellipse to be the set of all points. So I'm going to pick a random point. So the set of all points whose distances from two fixed points called the foci. So I'm going to mark the distances to those 2 points. So if I add those two distances together and I pick another point, any other point on the ellipse, and I draw the straight line distance to each of those foci, if I add up those two distances, they're going to be the same as the other sum. So any point that I choose, if I draw the straight line to each focus and add those two distances together, it's always going to be the same. That's the definition of an ellipse. So that's this idea behind the focus. And then we have all these other terms associated with an ellipse. So here, let's go ahead and take a look at them. We have the center of the ellipse. We have what's called the major axis, which is this line segment that's along the longer side of the ellipse, and then the minor axis, which is the line segment along the shorter side of the ellipse that passes through the center. And along the major axis, we also have the vertices, which intersect the major axis and the actual ellipse. So we're going to be interested in finding these key aspects of an ellipse. Let's go ahead and take a look at the standard equations for an ellipse. Now, they seem a little bit intimidating, but when we get into an example, you'll see that it's not really too bad. So first, note that a squared is greater than b squared. So a squared, the number in the denominator here, we want to think of it as always greater than the number b squared. And then we have this equation, c squared equals a squared minus b squared, that deals specifically with an ellipse to find those foci values, as you'll see in the formulas here. So we have two different equations for an ellipse. We have x minus h squared all over a squared plus y minus k squared all over b squared equals 1. And this is an ellipse because we have the variable x is squared, the variable y is squared, and they are added together. And this ellipse has a major axis that is horizontal. So for example, this picture here, the major axis is horizontal because the value of a is below the variable x. So remember, a squared, is bigger than b squared. So if the number below x is bigger, then the major axis is horizontal. As opposed to this formula over here is y minus k squared over a squared. So a is the bigger one. A corresponds to y now. and then plus x minus h squared over b squared equals 1. So this is an ellipse because y is squared, x is squared, they're added together, everything's positive. But the major axis is vertical because the bigger number, a squared, is below the y variable. So when I think about the y variable, I should think the y-axis up and down. So it would be like taking this ellipse and turning it on its side so that the longer side goes up and down. So that's how to tell the difference between a major axis being horizontal and a major axis being vertical. It depends on if the bigger number is below x or the bigger number is below y. And then to find the center, it's the opposite of the number by x, the opposite of the number by y. The center is hk. And then the vertices and the foci have formulas that depend on the values of a and c. So here a, again, is the number, the bigger number between the two denominators, and then c is found using this formula here. So I would actually say it's not really worth it to memorize these formulas that get us the all these different points. We're going to find these values as we start to graph the equation. Let's take a look at an example. Sometimes the formulas can feel a little overwhelming, but as we do the example, everything becomes a lot clearer. So given the ellipse, x minus 2 as a quantity squared over 25 plus quantity y plus 1 squared over 9 equals 1. Find the center, vertices, foci, and graph it. So here we're told it's an ellipse, but we should also know it's an ellipse because we have x variable squared, the y variable squared, and everything is positive and added together here. So we want to make it look like the general formula. So I'm going to rewrite the denominator 25 here as 5 squared and then 9 as 3 squared. So we can see this is like my a squared and my b squared. Since 5 squared is the bigger denominator and it corresponds to x, we know that the major axis is going to be horizontal. And we'll start by identifying the center. The center is hk, the opposite of the number by x, and the opposite of the number by y. So my center is positive 2, negative 1. So I'm going to go ahead and start by plotting that value at positive 2, negative 1. Now we have to find the vertices, foci, and graph it. So I'm going to go ahead and graph it first before I find the vertices and the foci, because the process of graphing it is actually pretty easy. Once you identify the center, what you're going to do is look at the number that's below x, so in this case 25, which can be written as 5 squared, and when we rewrite it as a number squared, that value, so in this case 5, is the number of units that I go right and left from the center to find the vertices. So from 2, negative 1, I'm going to count 5 units to the right, 1, 2, 3, 4, 5, so it's going to be at 7, negative 1. And then 5 units to the left, 1, 2, 3, 4, 5, negative 3, negative 1. So those are going to be my two vertices. They're along the major axis because we said the major axis is horizontal. Then, to know how much we go up and down, we're going to look at the number that's below y that's being squared. So that's why we wrote 9 as 3 squared, because we're going to go 3 units up and 3 units down to complete those 4 points so that I can connect them and create my ellipse. So if I go 3 units up, it'll be 2, 2, and 3 units down, it'll be 2, negative 4. So those are actually called semi-vertices because they're along the minor axis. So now we can go ahead and graph it. We can connect these points together. I'm going to see if I can get it to do a nice job for me. There we go. So I've graphed my ellipse now. And when in the process of doing that, I actually now have found the coordinate points of my vertices. My vertices are along the major axis, so I found out they are at 7, negative 1, and negative 3, negative 1. So those are my vertices. 7, negative 1 is 1 point, and negative 3, negative 1. So now all I need to do is I need to find my foci values. And the foci live along the major axis, so I'm going to go ahead and just put a dotted line there for my major axis, and they lie inside the ellipse. Right, so they are equidistant from the center, so it's going to be the same amount of units right and left, and that amount that I'm going to go right and left is actually the value c. So I'm going to go c to the right and c to the left. I don't know exactly what that is yet, so I'm kind of making it up here. Because how do I find the value of c? Well, there is a formula for that, and that's the one formula that you really do have to remember. So the formula is c squared equals a squared minus b squared. So a squared is the bigger denominator, and b squared is the smaller one. So this is really just bigger minus smaller here. So 25 minus 9 is equal to c squared. C squared is equal to 16, so c is equal to plus or minus 4. So we can see that the distance I travel to the right and to the left is going to be 4 units. So I was off a little bit here. Right, I want to go 4 units to the right and 4 units to the left. So that's going to bring me all the way to 6, negative 1, negative 2, negative 1. So that is that distance of c here. So the value of c is that 4 units that we're heading to the right and to the left. So I know my foci values are 6, negative 1, and negative 2, negative 1. And we found them by, again, finding the value of c and adding that value of c to the right and to the left, the center. In this example, given the ellipse 16x squared plus 4y squared equals 64, find the center, vertices, foci, and graph it. Alright, so again, we've been told we're given an ellipse, but we should know that because we see the x variable squared, the y variable squared, and everything here is positive added together. It doesn't quite look like that general form that we have, and that just means that we have to do a little bit of algebra to rewrite it like that. So we have 16x squared plus 4y squared is equal to 64. We want it to equal 1, so we're going to divide both sides by 64. And then we're going to go ahead and simplify here. So 16 goes into 64 4 times, so we have x squared over 4. And then we have y squared over 16, 4 over 64, equals 1. So we can rewrite the denominators as 2 squared and 4 squared. They don't always have to be perfect squares, but in this case they are, because we can always take any number and write it as the square root squared. But in this case we have 2 squared and 4 squared. And so now we can go ahead and start finding all of our pieces and graphing. So let's go ahead and identify the center. Well, the center of this ellipse, I'm going to move this over, is just 0, 0, because here I have like x minus 0 squared, y minus 0 squared. So the center is just 0, 0. The center is at the origin. And then, let's see, the number below x that's being squared is how much I go right and left. So I'm going to go to the right 2 and to the left 2. And then the number below y that's being squared, so 4 is being squared, that's how much I go up and down. So from the center I go up 4 units and I go down 4 units. So from here we can see that the major axis is going to be vertical this time. And we could have identified that from the actual equation because 16 is bigger than 4, and the number that's bigger in the denominator, if it corresponds to the y variable, we think up and down for vertical. So we're going to go ahead and connect these together. Oh man, I thought it was going to make it nice for me. Can move it. Okay, that's not too bad. Nope, it's a little bit crooked. Imagine that this is perfectly up and down. So that's the best I'm going to get to do here. So here is my center, 0, 0. Here is my ellipse. We graphed it. So we know that the major axis is vertical. And therefore, the vertices are these values 0, 4, and 0, negative 4. So the vertices are always along the major axis. So the vertices are 0, 4, and 0, negative 4. And then finally we need to find the foci, but there is a formula for that. So we're going to say c squared is equal to, I want to think about it as the bigger denominator minus the smaller denominator, 16 minus 4. So c squared equals 12, or c equals plus or minus 2 radical 3 after I simplify the square root of 12. So my c value is 2 rad 3. So that's how much I go up and down from the origin. That's how much I go up and down from the origin to find c. So, I'm sorry, to find the foci. So c is 2 rad 3 up, and then I'm going to go 2 rad 3 down. Well, it's kind of nice because then that means it's getting me to the point 0, 2 radical 3, and then 0, negative 2 radical 3. So those are going to be my foci points, 0, 2 radical 3, and 0, negative 2 radical 3. And those are going to be within the ellipse. So we know that this was square root of 12, which is definitely less than the square root of 16, which is 4. So we always just want to make sure that we are definitely within the ellipse and along the major axis. In this example, we'll work backwards. We're going to write the equation of the following ellipse. So first, let's go and identify what the center is. We can see that the center is going to be right here at 1, 0. So we have the center is 1, 0. That's my HK. And then we want to see how much we go to the right and left and how much we go up and down to get to our vertices and our semi-vertices. So we see this distance here is going to be 2 units, right and left. And then up here, I'm up at 1, 7, so I'm going to go 7 units up and down. All right, so let's go ahead and write the general equation and fill in our parts here. So it's going to be x minus h, so the h value of the center is 1, x minus 1 squared over, in general, it's going to be the number that I go to the right and left from the center, or that quantity, and that's 2, so over 2 squared, plus we're going to have y minus k squared, well k was 0, over the number I go up and down, or the amount I go up and down to reach the vertices in this case, which is 7 squared, is equal to 1. So this is the generalized version, but we're going to clean it up a little bit to look like x minus 1 squared over 4 plus y squared over 49 is equal to 1. In this example, we want to write the equation for an ellipse with center 0, 0, focus 3, 0, and vertex at 5, 0. So we have this value of h and k because we have the center 0, 0. And we also have one of the foci, a focus 3, 0, and one of the vertices at 5, 0. So what we can go ahead and do to sort of help us out is that we can graph this so we can just think about it a little bit more visually. So we have our centers at 0, 0, and I'm going to go ahead and label our vertices at 5, 0, and negative 5, 0. So how do I know negative 5, 0? Well, if the center is 0, 0, and one of the vertices is 5 units to the right, the other is going to be 5 units to the left. And then we know that we have a focus at 3, 0. Let's go ahead and mark 3 there. And then over here at negative 3, we know we have another focus. So I'll just put a little F there and a little V here. And then this is the center. Okay, so since the vertices are along the major axis, I know that my ellipse has to look something like this, right? Where the longer side is along the horizontal x-axis here, and then the minor axis is along the y-axis in this case. So what I'm missing compared to, let's say, the last problem is I'm missing how much I go up and down. I don't know what these labels are right here. Up here and down here. I don't know how much I go up and down from the center. So we can start to fill in a couple of things. So we can go ahead and say, well, we know that we have x minus 0 squared over 5 squared. So we definitely know that much because that's the number I go to the right and the left from the center, plus y minus 0 squared over, and here's what we're missing. We're missing that value of b, right? B is the smaller number. We know it's smaller. That's how much I go up and down, equals 1. Okay, but here's what I do know. I know the value of C, because C is the distance from the center to one of the foci, right? A focus. So C is 3. And I do know that formula that says C squared equals A squared minus B squared. So if C is equal to 3, 3 squared equals 5 squared minus B squared. So I can solve for B squared, which is what I need in this formula still. So to solve for B squared, I'm going to add B squared to the left side, subtract 3 squared to the right side. So I get 25 minus 9 is 16. So the value of B squared is 16. So there's no need to like solve for B and take the square root of both sides because I need B squared anyways. So B squared is equal to 16. So this nice version here is going to be x squared over 25 plus y squared over 16 is equal to 1. So it turns out the amount that I go up and down is actually 4, because we can rewrite 16 as 4 squared. In this example, we have graphed the ellipse x squared plus y squared plus 8x plus 4y plus 16 equals 0. So we're told this is an ellipse, and we can also see x is squared, y is squared, and we have that those are both positive terms, but it definitely doesn't look like an ellipse, and that's because we have to do a little bit of work to put it in that standard form. And that work is going to require us to complete the square. So what I'm going to do is set us up to complete the square. I'm going to write this as x squared plus 8x, and then I'm going to leave myself a little bit of a gap here, and then I'm going to put the y variables, so plus y squared plus 4y, and then I'm going to leave a little bit of a gap here, and I'm going to subtract the 16 to the other side. So I'm leaving the x terms first, and then I'm putting the y terms next, and I'm moving the constant and subtracting it to the other side. And so now what I'm going to have to do is complete the square for each variable. So if you recall, completing the square is, since the leading coefficient is 1, we're going to take the b term, we're going to divide it by 2, so 8 divided by 2 is 4, and we're going to square it. So 4 squared is 16. So I'm going to go ahead and add 16. So if I add 16 on the left side of this equation, I'm going to have to add 16 on the right side of this equation, right, to balance things out. So I can either think about it as adding 16 and subtracting 16 on the same side, because then that's like adding 0, or adding 16 to both sides, because then it will cancel out when you move it to the other side. Now I'm going to complete the square on the y variable. I'm going to take the b value, since the leading coefficient is 1, I'm going to divide it by 2. So that's going to give me 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4 to complete the square, and add 4 to the other side of the equation to balance things out. So now the right side of the equation is just 4, because 16 and negative 16 are going to cancel out. And the whole idea behind completing the square is that these trinomials are going to factor to perfect squares now. So this is going to be x plus 4 squared, and then plus the y variable trinomial is going to be y plus 2 squared. Okay, so now I'm starting to see that standard form of an ellipse take shape here. But I'm not sure if anybody noticed, this is actually the equation of a circle. So it has the form x minus h squared plus y minus k squared equals r squared. So we can proceed and pretend like we didn't recognize that, and we'll still end up graphing a circle if we use the ellipse method. So we have x plus 4 squared divided by 4 plus y plus 2 squared divided by 4 equals 1. So notice that the denominator is the same on both. So if we were to proceed, we would say that the center is -4, -2, the opposite of the number by x, the opposite of the number by y. So we'll go ahead and graph that point, -4, -2. And then remember what we do is the number that's below x and the number that's below y, in this case they're both the same, we rewrite it. so that it's something squared. They both happen to be perfect squares. So we're going to go 2 to the right and left and 2 up and down. And that's how we are creating a circle. So we're going 2 up, 2 down, 2 right, and 2 left. And if I connect those together, there we go, it's making it a nice circle for me. Right? And so there's no major axis, because if I draw a straight line, either straight up or straight down or really any direction, it's going to be the same every time going through the center because that's the diameter. So again, it turns out that this particular ellipse is actually a circle. So a circle is a specific ellipse, right? With the denominators underneath each variable the same, because then we can write it in that standard form of a circle: x minus h squared plus y minus k squared equals r squared. So the center is -4, -2, and then it turns out we found that the radius is 2, because we in fact have a circle. A circle is a special ellipse. Now let's take a look at the conic section of a hyperbola, which also has some unique applications. We won't be diving into those, but one of them is that the shape of the light that comes out of a flashlight has a hyperbolic shape, so one of these pieces of a hyperbola. By definition, a hyperbola is the set of points whose distances from two fixed points called foci in the plane have a constant difference. So if you recall from an ellipse, they had a constant sum. So if we pick a random point on the hyperbola and draw these straight lines to the foci, so if I find the difference between these two distances, the longer one minus the shorter one, and if I pick another random point and draw straight lines to each focus, if I subtract the shorter one from the longer one, that's going to be the same as subtracting the shorter one from the longer one over here. At any point that I choose, they will have a constant difference. So that's the definition. Let's take a look at some of the vocabulary involved with a hyperbola. So the hyperbola is, again, these two U shapes here. We have the idea of a center, again, which is going to be halfway between the two vertices of my hyperbola. So I have one vertex here, sort of the very bottom and the very top in this direction. I also have foci, right? The singular is focus, and those live inside of the U shape, right? So like inside the U is my focus. And then I also have something new, which is this idea of asymptotes. So these U shapes are approaching these linear asymptotes. And notice that the asymptotes do pass through the center of the hyperbola. Let's take a look at the standard equations for a hyperbola. Note that for a hyperbola, we have this formula that we're going to need, which is c squared is equal to a squared plus b squared. So here we have the standard equation for a hyperbola. We have x minus h squared over a squared minus the quantity y minus k squared over b squared equals 1. So the main difference is that we have subtraction between the two terms. We still have x squared, we still have y squared, but we have subtraction. Now, because the variable x is positive, as opposed to, I'm considering the variable y negative because the negative's in front of the y term. Since the variable x is positive, we know that our hyperbola is going to open to the left and to the right. So looking down here, we have a hyperbola that's going to open to the left and to the right. So I kind of think about it as like eating the x-axis, right? So because the x value is positive, it's like I'm eating the x-axis, my hyperbola. And then we have the different formulas for finding the center, the vertices, the foci, and the asymptotes. And then over here we have another version of the standard equation. This one has the y variable first, so y minus k squared over a squared. So this time the y variable is positive, minus x minus h as a quantity squared over b squared equals 1. So when the y variable is squared, that means that the parabola is going to open up and down. So it doesn't have to do with the numbers on the bottom, whether it opens right or left or opens up or down. It has to do with whether the x variable is positive, it opens left or right. If the y variable is positive, then it opens up and down. And we're going to go ahead and look at an example on how to find these values rather than, again, just kind of memorizing the different formulas for finding these components. In this first example, we want to find the center, vertices, foci, and asymptotes and graph the hyperbola. So here we have x plus 2 squared over 25, so 25 is 5 squared, minus y squared over 16, 16 is 4 squared, is equal to 1. We know this is a hyperbola because we have one of the variables is negative. We have a minus in front of the y squared. So because there's a negative in front of the y squared, that means that the x variable is positive, so this is going to open to the right and left. So I'm going to put a little note here, right? Like since x squared is greater than 0, it's going to open left and right. So I want to remember that. Let's go ahead and identify the center. That's an easy one to find. So the center is the opposite of the number by x. X is first here, so we're going to take negative 2, and then the number by y just happens to be 0. So I'm going to plot my center at negative 2, 0. And we're going to do something similar to what we did with ellipses. We are going to travel 5 units to the right and 5 units to the left because the number 5 is being squared is underneath the x value. So I'm going to go 5 to the right and 5 to the left. So 1, 2, 3, 4, 5. That's going to lead me to 3, 0. And then 5 to the left is going to lead me to negative 7, 0. And then I'm going to go 4 units up and 4 units down because that's the number being squared underneath the y variable. Okay, but this time, instead of connecting those with an elliptical shape, obviously, what we're going to do is those are going to become the midpoints of the sides of a rectangle. So if you look back to the standard equations and the pictures that are shown, you'll kind of see this dotted line rectangle on the graph. And it's not a part of the graph, it's just a guide to helping me draw the graph. And so you'll see why now. I'm going to go ahead and create a little rectangle where those points, again, are the midpoints of the side length. So of each side of the rectangle. Doesn't want to make that a straight line for me. Okay. Sorry, that line's going to bug me. There we go. Okay, so here's my rectangle. Again, those points that we went up, down, right, and left from the center, those are the midpoints on those points of a rectangle. So what we're going to go ahead and do with this rectangle is we're going to go ahead and draw a line that goes through the center and each of the corners. So we're going to create a diagonal that passes through the center and goes through each of the corners of my rectangle. So I'm going to go ahead and do that in a different color, but keep it a dotted line because those are going to be my asymptotes. So I'm going to go ahead and draw a line that goes through the diagonal, right? But it passes all the way through it and also through the center. Okay, so those are my asymptotes. All right, so before we clutter up the graph with a little bit more detail, one of the things we have to find is the equation of the asymptotes. And I'm actually going to do that part first because the asymptotes are these linear functions right here. So how do I find the equation of a line? So to find the equation of the line, one of the ways we can do it is to use the formula y minus y1 equals m times the quantity x minus x1. So if we know the slope and we have a point, we can find the equation of the line. Well, here's what's great. I have a point because each of the asymptotes goes through the center, which was negative 2, 0. So I have y minus 0 equals, I'm going to leave a space for the slope, x plus 2, x minus negative 2. So all I need is a slope. Well, to find the slope, I need to go through 2 points and figure out that rise over run. So I have the point negative 2, 0, and I can pick one of the vertices of the rectangle, right? One of the corners of the rectangle. So I can go, to get from this point to this point, I can go up 4 units and right 5 units. And I know those distances because that's how I found these midpoints, Right? I went up 4 and I went to the right 5. So my slope, right, my slope of this line right here, m, is 4 over 5. Now I can also find the slope of this line right here because that's the only difference. They both pass through the point 2, 0. So the only difference is the slope. Well, I would go up 4 but left 5. So my slope is negative 4 over 5. So my asymptotes are going to be y minus 0 equals positive 4/5 x plus 2, and y minus 0 negative 4/5 times the quantity x plus 2. Or sort of in a cleaned up way, y equals plus or minus 4/5 times the quantity x plus 2. So these are my asymptotes. All right, these are my asymptotes. Okay, so now that I have those, I'm going to go ahead and graph the hyperbola. We said that this opened right and left. So these points here that were 5 units away from the center, those are going to be the vertices. Those are going to be the vertices. So the asymptotes, I have to approach them. So here is one piece of my hyperbola, and I'm getting close to those lines, right? I don't want to like draw it really skinny or anything, so I don't want to like do something like this, right? I want to make sure that it's nice and wide. It goes through that point because that's the vertex. So we have a vertex at negative 7, 0. So let's list those. Vertices at negative 7, 0, and 1 at 3, 0. And then finally we have to find the foci. We already found the asymptotes. So to find the foci, we're going to need to use the formula c squared is equal to a squared plus b squared. So for a hyperbola, they're added together. For an ellipse, we subtract bigger minus smaller. So here, we're just going to add the two denominators together. So we're going to have c squared equals 25 plus 16, which is 41. So c is plus or minus radical 41. So c is radical 41. And that's the distance that I'm going to add from the center along the x-axis. I'm going to go horizontally. That's the distance that I'm going to add to get to the focus, which should be inside of the U shape here. So let's see. I'm going to go ahead and add the c value, radical 41, right, to go to the right. And then I'm going to have that same c value here, radical 41, going to the left to find my focus on each side. So how am I going to write those points, right? So this coordinate point right here is the focus. It's radical 41 to the right. So this point right here, the center, that was negative 2, 0. Let's not forget that. So we're adding radical 41 to the x component. So the focus is going to be negative 2 plus radical 41, comma 0. I mean, don't get confused because it's a square root number. I mean, think about it if it's just the number 7. If it's the number 7, we're going to add negative 2 plus 7, and it's going to get us to the point 5. But it's not a nice integer number, it's square root of 41. So we're just going to tack on plus square root of 41 to negative 2, and then we're going to subtract it to go the other direction. So negative 2 minus radical 41, comma 0. So those are my foci values, which we can write as negative 2 plus or minus radical 41, comma 0. In this example, we want to find the center, vertices, foci, and asymptotes and graph the hyperbola 4y squared minus x squared equals 4. So this is a hyperbola because y is being squared, x is being squared, and then one of them is subtracted, right? One of them is a minus. But it doesn't look like standard form, so we're going to go ahead and divide everything by 4 to get that equals 1. So we're going to divide by 4, divide by 4, divide by 4. We have y squared over 1 minus x squared over 4 is equal to 1. So now let's go ahead and identify the center. The center is 0, 0. So the number next to x and the number next to y in this case is both 0. And let's also just take a second to recognize what direction this is going to open. Since the y variable is the positive one, right? We have minus x squared, but here this is positive y squared. This is going to open up and down. So since that y squared is positive, it's going to open up and down. So let's remember that. So let's go ahead and plot the center. And let's see, from the center, how much are we going to go right and left? Well, 4 is 2 squared. 1, of course, is 1 squared. So from the center, we're going to go 2 to the right and 2 to the left. And then the number below y is how much I go up and down. So I go up and down 1 unit. And then those become the midpoint of this rectangle side length that I'm creating. So let's go ahead and create that rectangle. And through the diagonals, right, so through the corners of the rectangle and through the center, I'm going to create those diagonals. Those diagonals are going to be my asymptotes. So let's see if I can make those look nice. I want to go ahead and extend them, make sure they go like all the way through, because they're going to help guide my graph in a second. Okay, so let's write the equation of those asymptotes right now though, right? Let's just get those out of the way. These are actually a lot easier than the last ones because these pass through 0, 0. So the y-intercept is 0. So to write the equation of these asymptotes, I can actually use y equals mx plus b, right? So y equals mx plus 0 because the y-intercept is 0 on this one. I just need the slope. So what's the slope? Well, I go up 1, right 2. So the slope is going to be 1/2 on the positive slope line, and then up 1, left 2, so negative 1/2 on the negative sloped line. So I have an asymptote of positive 1/2 and negative 1/2 x. So altogether, we have plus or minus 1/2 x as our asymptotes. And then let's go ahead and sketch the graph, and we can identify our vertices and then find our foci. If we sketch the graph, remember it's going to open up and down because the y variable is positive. We're going to go ahead and open up this graph, make sure it goes through that point right there, one of the midpoints of the rectangle. And then here, we're going to go ahead and sketch the other part of the hyperbola. So we can see that our vertices are going to be those points along the y-axis, 0, 1, and 0, negative 1. And then we need to find our foci. So remember, our foci are going to have to live inside the parabola. I don't know exactly where they are, but I'm going to need to find this distance right here, this value of c. And so to find the value of c, I'm going to need to use my formula, c squared equals a squared plus b squared. So we're adding the two denominators together. So c squared equals 1 plus 4. C squared equals 5. So c is plus or minus rad 5. But really we want to think about it as that distance. So c is radical 5 up and radical 5 down from 0. So that's not too tough. Right, so this point up here is 0 rad 5, and down here is 0 negative rad 5. So my foci, there's 0 rad 5, and then 0 negative rad 5, which yes, you can combine to write a 0 comma plus or minus rad 5. And even here, 0 comma plus or minus 1. And in this example, we'll work backwards, we'll identify the center and write the equation of the following hyperbolas. So over here off to the left, let's identify the center. We can see that the two asymptotes meet there. They intersect at 0, 1. So that's my HK. And I want to write the equation of the hyperbola. So let's recognize that this hyperbola opens right and left. So the variable that needs to be positive is the x variable. So we'll start by putting x first. So x minus 0 squared, because the the center, x value is 0. So x minus 0 squared. and then I'm going to leave the denominator for a second, and then minus y minus 1 squared over, and we'll figure that out in a second, equals 1. So now, what is the denominator here? Well, x, if I think about the x-axis, are going right and left. If I count my tick marks here, I'm going 1, 2, 3, 4, 5 units to the right and 5 units to the left from the center to get to those vertices. So that's the number below x, 5, which gets squared. And then how much do I go up and down? So 1, 2, 3, 4 units up should be the same going down, 4 units down. That's the number that I put below the y variable. So if I clean this up a little bit, I'm just going to move it over, I'd get x squared over 25 minus the quantity y minus 1 squared over 16 is equal to 1. Now let's take a look at the next graph. If we identify the vertex this time, or the center this time, excuse me, the center is 0, 2. Keep wanting to call it a vertex, but it is a center. So the center is 0, 2. This time, notice that the hyperbola opens up and down. So that means that the variable that's got to be positive is the y variable. So the y variable is going to go first. So we're going to have y minus 2 squared, because I'm looking at the second coordinate, the k. So y minus 2 squared over something, we'll find that out in a second, minus x minus 0 squared over something equals 1. So how much do I go up and down to create my little rectangle? I go up and down 2 units, so we'll have a 2 squared. And then I go 1, 2, 3, 4, 5 units right and 5 units left. That's the number that goes below the x variable. So if we clean this up a little bit, we're going to get y minus 2 squared over 4 minus x squared over 25 is equal to 1. So first we identified our center, and the next thing that we do need to know is which direction it opens, because that's going to affect which variable goes first or which variable is positive. And then we can fill in how much we go right and left and how much we go up and down to create those guiding rectangles on our hyperbola.